Hello, hello. I think I'm live. Am I live? Can you see me? Can you hear me? Checking everything here to make sure it looks like I'm live. So I'm not just talking to myself because I've done that before. Uh, Doing a solo show means I have to do all the checking myself too. It looks like I'm good. Let's, well, hang on. Let me refresh. YouTube still says upcoming. Okay, I'm not sure if this is working. Hang on. If you're If you're hearing my voice, oh, it looks like I'm live now. Okay. If you're hearing my voice, would you just say in chat hello or hi or I'm here or nice hairdo, anything like that to let me know that you're alive. But it looks like I've refreshed now and I think we're good to go. So thanks for joining me today. Hi, I got a hi. Great. So at least one person can hear me. So today I'm going to start with an Ask Me Anything session, and we'll see how many questions I get. I have 2 hours set aside. I don't think I have 2 hours of questions. I'm guessing more like 15 or 30 minutes, maybe, but we'll see. Um, and then I'll get into some live coding with whatever time remains. So the first question I have today, somebody asked on YouTube and by email, but I got it both places. Um, is why doesn't the math package use generics, or why does the math package still not generic? Is the question. So let me pull up the documentation for that. I'll share my screen here. I'll put the documentation for that so it's clear what I'm talking about. I'll give an answer. All right, share my screen. Present. Share screen. All right. Let me see if I can make this like a picture in picture. Yeah, it's a little better. I wish I was on the other side of the screen, but I won't worry about that today. So here's pkg.go.dev, and we're looking at math, not math rand, just math. I'm going to zoom in a little bit, make this full screen. So the question is, why do we have, why is it not generic? And I suppose, so it's using floats just about everywhere. I suppose the question is, why can't you like pass in an integer to some of these? Some of these don't make sense. ABS isn't, it wouldn't make sense. But like, why can't you do the cosine of an integer or the min and max of an integer? That would make sense, right? Um, so some of these could in theory make sense with integers or float 32s for that matter. Um, why isn't that possible? And then the person asked also, I expected after Go 1.18 when generics were introduced that everything would change. So I have a multi-part answer to this. Um, the first answer, and this is probably fairly obvious, is we can't change the existing uh, function calls. We can add new functions. So we could add in principle we could add generic functions of some of these or versions of some of these, but we can't change the existing ones because that would break backward compatibility. And Go is very strong on its backward compatibility promise. That's one of the selling points of Go is that you can upgrade your Go software to run on newer versions of Go without problems like we have in the Python world between 2 and 3 and stuff like that, or even with different versions of Node.js or almost any other language. Sometimes you upgrade and they deleted some old feature or they changed the way it works and now things are broken. You have to go in and change your code. Go is very strict about maintaining that backward compatibility. There have been a few small exceptions. The most obvious one was in just Go 1.22, which came out last month, where they changed for loop semantics, but they did it in a very careful way, so your old Go code will still work, even with the new version of Go. That's a different topic. If someone cares, I can talk about that. But so that's the first part of the answer is they can't just change the existing thing. So let's suppose we wanted, um, let's say, Max to also support float 32s and integers and so on and so forth. They couldn't change this one; they'd have to add a new one. So that's the first part of that answer. A second small part of that answer is that in some cases they did. So min and max actually are the two cases I want to talk about. Those are generic and they're built into the language now. So effectively, um, math.max and math.min are effectively obsolete now because you can just use lowercase max and lowercase min, which are built into the language, for any numeric type. Let me pull that up just to show you. I think we can look up. I think it's called built-in, or is it built-ins? I'm not sure how to find that Go doc. I know it exists. Can I search for symbols? No, I want to search for max. This is built into the standard library. That's not helping. Let's do a Google search. It'll get me there. I want the Go doc for it if possible. Well, I'm not finding it, and I'm not sure exactly how to find that. Go doc for built-in function. Let's go there. See if that helps. Built-in package. That's what I was looking for. I didn't find it for some reason. All right, so here we go. So here's the max and min. You can see these are generic. They have a type parameter here, and they take any type that is ordered. So it's even more broad than numeric values. It can be any type that is numbered or ordered, I should say. The third answer I have to the original question would be that min. Whoops, I didn't mean to close all of that. So yeah, my third and I think final answer to why it's not generic is many of these operations make very little sense. So some of them make literally no sense on non-float types, and many just don't make sense on integer types. Like taking the cosine of an integer probably isn't very valuable in most cases. I could see a case for POW. Taking integers to powers makes sense. Remainder doesn't make sense except on floats, although I could see a case for float 32 being supported. So many of them just don't make sense on non-float types, and so I think, I mean, an argument could be made for float 32, and even in those cases. But most of the time, when you're doing arithmetic, you want the more precise version. Maybe you do your exponent calculation on a float 64 and then convert it to a float 32 if you're using float 32. But I mean, an argument could be made, I think, to support float 32 in virtually all cases if you wanted to, and then in a few cases, integers might make sense, but they aren't very practical for things like sines and cosines and tangents. You want floating point for that sort of stuff. I hope that answered that question. If you have more follow-up, feel free to ask. Let me move on to the next one here. Do you think that optionals should be introduced into Golang? Do you mind explaining what you mean by optionals? I can think of a few different possible interpretations of that. So if you can follow up on there, let me know what you mean by that. I'll get back to that question. I see some hellos. Hi, Dennis. Good to see you here. How should I test my service which uses a database? Should I mock the database or other container, for example? Oh, this is a great question because it comes up all the time. I don't like. I'm going to say something, and then I'm going to tell you the exception to it. so hang in there. Don't get upset at me before you hear my exception. I don't like mocks. Mocks are heavily overused in testing. In all languages, really, in my opinion. Go, in particular, has a culture to use fewer mocks than many other languages, although this isn't a principle specific to Go. It's just mocks are overused in many, many languages. So when it comes to database, databases are one of the rare exceptions where I do use a mock sometimes, but I do it in a very particular way. So the way I handle this is I will write my change the screens. You're not staring at GoDoc. That doesn't matter right now. So what I typically do is I will write a very thin. I'm assuming you're using a SQL database where you're writing queries, whether it's with an ORM or something like that. Um, if you're writing queries in particular, this what I'm talking about is relevant, and I prefer to write my own queries. So what I'll do is I'll write a very thin database access layer that where I write my own raw SQL usually, sometimes lightly generated SQL. But I do that in a very thin layer, and I will write, and I will typically test that against a live database. That does mean those tests are fairly slow, and they require some startup. I often use test containers to start up MySQL or Postgres or whatever in a test container, run the test, and then shut down the container. That startup takes about 30 seconds or so, so it's kind of slow for like for doing testing on save. If you want to do that, which I often like to do, then I use Docker Compose or something to start that container and let it run in the background. Um, so in that case, I'll run my test against a live database. Okay. Uh, but that's a very thin layer. And basically, the reason I use a live database there is because it's actually important to test that my queries are correct, that the SQL syntax is correct. If you're using an ORM, you might skip that. You might trust your ORM to do it all correctly, or at least in most cases. I don't like ORMs though for reasons not related to this question, so I'm not going to get into that. But that's how I do that layer. And then on top of that, I'll have my sort of um, a logic layer of some sort, a repository layer or something like that. And I will, and that talks to those database endpoints I just created. Endpoints isn't the right word, but those database functions that I just created. So those database functions themselves are tested against a live database, but then that the talk the communication between my application and that layer I just wrote, I'll use a mock for that, or stubs or something like that. That way, I don't need a live database for those tests. That's why I do it that way. So I should have started with this actually. I want to make a distinction between mocks and other types of test doubles or test implementations. A mock acts like the application that you're mocking, a database, right? So you can use there are mock generators, mock gen, and there's many of them, and there are specific ones for SQL, and I do use those occasionally. I'll talk about that in a moment. I told you there's an exception. Um, but in a mock will mock. Let me actually pull up an article that will help explain this better. This is a Barton Fowler article. Share it on my screen here a second. All right. It's called Mocks Aren't Stubs. And the whole point of this article really is to break down the different types of dummy objects we use in testing. I'm not going to, of course, read the whole article here. He has a list here somewhere that I think he does here. All right. So these are the different types of test doubles that Martin Fowler enumerates in this article. Dummies, fakes, stubs, spies, and mocks. Mocks are the heaviest of these. Now, many people use the word mock to mean any of these things. I wish they didn't, because it's confusing. I mean, if you mean a fake, but you say mock, I don't know what you're talking about. Which means that whenever anybody asks me about this, and maybe I should have done this just now. If you're asking, do you use mocks? I might ask, what do you mean by a mock? But just to be clear, this is what I think of. I tend to follow Fowler's terminology more or less. So starting from the simplest version, a dummy is an object that's passed around but never actually used. It's just there to fill parameter list. In Go, sometimes it's just the word nil. Maybe you don't actually need an object there at all, or maybe you need one that just won't panic when it's accessed or something like that, right? Which gets you close to a fake, which is an object that has a working implementation but takes a shortcut. So a typical example of a fake would be in the realm of databases, maybe something that always returns 0 results, right? It doesn't give an error, it doesn't panic, but it will just if you ask get user, and it'll just return 0 users every time. Stubs are a little more complicated yet. They return canned answers. So you might have a stub that always returns Bob. You say get a list of all users, and it just always returns Bob, no matter what else happens. That would be a stub. You have a spy, which is a little more complicated yet. A spy actually does some amount of recording of what you did to the object, so that you can probe that information later. That's useful if you're trying to say, let's say you want to see how many times was the user's function called. Then a spy could, keep a tally, and then you check later it was called 3 times. And I expected it to be called 4, it was only called 3. That's a problem. Mocks, unfortunately, the word that people use to mean all of these things, and that's the heaviest one that actually acts like the application in some more advanced, sophisticated way. I try to avoid mocks. If I'm tempted to use a mock, it usually means I probably should be testing against the actual thing itself. So if I'm attempted to use a database mock, it probably means I should be testing against the actual database. So now I'm going to get into that exception I mentioned. The main reason I want to test against a live database is because I want to test the SQL queries, the SQL syntax itself. And a mock can't do that for me, or at least not in a reasonable way. I could, in a mock, assert that I got the exact query I wanted, or that it has the correct fields or whatever. But that's really cumbersome. It makes for very brittle tests because I have to encode all the expectations of my test on both sides. I'm really testing implementation at that point. So again, I will usually write my database test against a live database. Sometimes I will use a database mock for some of those tests. So let's say I've already tested the SQL that my user's function generates is correct, because I have a test that does that. I hope it's not too loud. An airplane's flying overhead just now. I can't hear myself, so I'm pausing for a moment. So let's say I have a test that does a live query against a live database with my user's function. And so I know that the SQL it generates is valid and correct because that test passes. But I want to test it with a few other different things that are less critical to the syntax. Like I want to test that when I pass in a particular parameter that the user is set to delete it or something like that. I might use a mock for that sort of thing. And then because I don't care about, I've already tested that the general syntax is correct. Now I just want to test for some smaller, lighter weight things. I might use a mock for that. I could also probably use a stub or a spy for that if I don't want to go full on with a mocking library. But that's the type of place where I might use a mock because it's faster. So then I could have, so let's say I have 10 tests ultimately for this user's function. 1 or 2 of them might talk to the live database, and the other 8 or 9 might use a mock or a spy. So that's how I do that. And then again, going back to what I was saying earlier, I have that layer on top, the application that talks to the database layer. I would use a stub or spies or fakes there. So I would not have to have a live database when I'm testing that part of the application. I would have a dummy, a spy, a stub implementation of my database layer that I can use for that testing. I hope that helps. I hope that's a good amount of detail. If you need more, let me know in chat. My next question here. Hi, Jonathan. How do I level up after getting comfortable with the language primitives? Any book recommendations for learning the language idioms? Pardon me 1 second. Great question. Last year I did a series of book reviews, and I'm hoping I have the time this year to update them since new books have come out. But I have 2 recommendations for you here. Let me just pull up my. Yeah. So I have 2 recommendations. I think I want to see the full list. It's down here. Learning Go. So my go-to recommendation at this point, this is essentially the conclusion of my review series last year, is Learning Go by John Bodner. He has a second edition that just came out last month. I got my copy. It's downstairs, right? Show it up here. Show it to you. If you haven't already read that one, that's a great starting point. It does assume you know programming. It doesn't assume that you know Go. If you already know Go and you're looking to go a little bit deeper, my next recommendation would be this one called Go Fundamentals. It's by Mark Bate and Corey Lanou. It's a thicker book. I think it's 500 pages or so. I have a broken iframe here. I'll just fix that later. It's a thick book, but it goes into a lot of detail, sometimes too much, which is the only reason I really don't recommend this one as like a beginner's book. It just goes into a lot of detail. If that's what you want, this is an excellent book for you. It's very, very thorough. If you're looking for something, if you're looking for something more like tutorial based, there's another book on the list that I would recommend. I don't think it's quite complete yet. Learn Go with Pocket-Sized Projects. It's more of a project-based approach. And at the time I wrote this review, which was about a year ago, February, March last year, I think they had 3 chapters done, and it was scheduled to be released at the end of last year. I think it's not quite done yet. Let me just look over on their website, see what that looks like. Nope, that's not what I want. I want to see the actual book. It's an early access, so you can buy it and read it already. It looks like it's going to be published in April, is what they're estimating now. They were estimating October this time last year. So April, maybe a little bit later. But already you can read 9 of the 12 chapters. So it's a good book anyway. But it's more project based rather than like conceptual, talking about syntax and the concepts. So depending on your learning style or what you're looking for, one of those 3 books would probably be a great place to go. And then from the same asker, on the same lines, would you recommend any Go repo as reference to understand the best design practices, like goals of using interfaces, good separation concerns, etc.? I've had similar questions in the past, and I'm not sure if I have a good answer. Let me check one thing quickly. I remember a conversation about this over on the Cup of Go channel a few months ago. Cup of Go is my Go podcast, by the way. Shaina Kamad and I do a weekly news podcast about Go. Head over to cupofgo.dev if you're not familiar. You can subscribe there. But we talked about this a while back. Do a quick search here. Because somebody we had a news article. Somebody had written asking the same question on Reddit, I think, and we were looking for an answer, and somebody pointed out. So I'm not finding it right now. The irony is that the largest Go project in the world, Kubernetes, is very non-idiomatic. So is the Go standard library in many ways. It used to be idiomatic, but as performance becomes more important, I think this is true in any language, in any project. You start idiomatic, and then as performance needs start to become more important, you'll tweak things in ways that are less idiomatic to be more performant. And the Go project is a good example of that, I think. Kubernetes also, I don't know if it's an example of that, but it was never really written in an idiomatic way. So unfortunately, I don't have a good answer for you on that. You could, if you get the book I just recommended, the Learning Go with Pocket-Sized Projects, I believe all of the projects in the book are available on GitHub, or maybe it's a zip file. I don't know how that's distributed. Maybe this will tell me. You can download an archive of some sort. It's a zip file. So you could look at that. It's not going to be a big project. It's toy projects, so it's not probably what you're looking for. I could point you to my open source project. It's not that big. And I also wouldn't make the claim that it's necessarily idiomatic because I've been writing this since 2017, and there's a lot of things I would do differently if I were doing them today. Some of those things I do change over time. I wonder if this give me like a line count somewhere. I'm not sure. It's basically a big REST API client. So if that's relevant to you, you could look at this for some inspiration. But like I said, a lot of this code is old and uses design patterns I wouldn't recommend. But not all of it. I mean, some of it's still, I think, solid. Yeah, I don't know. I'm sorry, I don't have a really good answer to that one. If I come across a repo like that or repos, I need to make a list because this question comes up now and again. So we got going back to the question about math. I accept that doing the sign of an int doesn't make sense, but would it make sense for float 32? Yes, I think so. I think it would make sense for float 32. Although it's not that difficult to do it in float 64 and convert again. All right. Okay, so back to the question about optionals. Something to avoid nil values like an optional in Rust. Let me look that up here. I've never done Rust yet. So let me just do a quick primer on what that is here. Okay, so it looks like it's kind of a way to. Let me share my screen. I'll just put this window on my screen so we're all seeing the same thing. So here's an example of function. So the third argument here is optional. What? I guess it's a way to like provide default values. Is that it, or okay, something that might exist or might not exist. And so the question was, let me refresh my memory here. Do you think the optionals should be introduced to Go? Um, I think I can provide a diplomatic answer and say it depends. It depends on the implementation they come up with. Like, I mean, I've seen things like this in various other languages, and each language has their own sort of way of handling it. And some of those would be very not Go like. Yeah, I don't have a strong opinion on it. Like as far as like preference, should they add it or not? In that sense, I don't know. Will they? I think it's going to depend on whether or not we can come up with a good syntax to do it, and whether it solves a big enough problem. So yeah, I don't have a good answer to that. I'm sorry. Have you ever used? Okay, this is a great question. Have you ever used a finalizer function? No, I have not. And I don't think I ever would. I mean, it would be rare that I would like. So before I talk about that, what is a finalizer function? If you're not familiar, a finalizer function. Let me see if I can just look it up here, so I don't give a silly answer. So you can, using the runtime set finalizer function, you can set a finalizer on a value. So in this case, a underscore foo is the value, and the finalizer, which I guess is defined here, gets called essentially when a underscore foo is garbage collected. So some languages will let you have like a deconstructor or something like that. It's kind of similar to that. However, there's some big caveats to this, which is probably the main reason I would never use it in Go. Aside from it being sort of subtly magical, which I don't like, um, Like I did use something like this when I was a Perl programmer at times, although back then I didn't have any qualms with using magic. I thought magic was cool. um, so if you want to, let's say you have a variable in memory that's also persisted on disk, and you want to delete the file when the variable goes out of scope, so that whatever's on disk matches what's in memory. It's a made up example, but let's imagine that's what's going on, right? So you could have your finalizer delete that file from the disk when it goes out of scope. Except that in Go, it's not when it goes out of scope, it's when it's garbage collected, which could be sometime well after the fact that it goes out of scope, which is the big limitation here. So um, in Perl, it would happen when it goes out of scope. So I could be relatively certain that whatever's on disk matches what's in memory. That's not so in Go. Now, there are still times, obviously, when a finalizer is valuable or else it wouldn't exist. I don't know what they are. I've never needed it before. I think they are used a few times in the Go standard library. I couldn't tell you where. So it's going to be very, very unlikely that you'll ever use that. So that's my answer there. No, I've never used it. And if I ever feel the need to, I'm going to look very hard for alternatives because of that big limitation that it doesn't happen when it goes out of scope. It happens uh, when the uh, when the value is garbage collected. And I don't know the answer to this. I don't know if it's guaranteed to happen. If your program exits before it's garbage collected, I don't know if that finalizer actually runs. I would have to look that up. If I ever am tempted to do this, I'll look that up. But that's an important question to answer, right? So following up on the question with the optional parameters, we have the comment that Go already forces you to handle errors. Why not force you to handle nil values as well? Um, well, it forces is in quotes. Yeah, I was going to say, like, it doesn't really force you to handle errors. I see a lot of people, unfortunately, ignore errors. I mean, it does force you to handle nil values in a sense, in that you'll get panics if you try to use nils inappropriately in many cases. But I think a case could be made that it needs to happen. It needs to be stronger than that in some cases. Um, I don't know. I just don't know what that would look like. There probably have been proposals about this. If I see a good proposal uh, about solving that problem, I would love to see one, and then I'll probably weigh in on it, probably on the Cup of Go podcast with my co-host. But yeah, I don't know what that would look like. So and also like I just said, and like you sort of implied in your question, it doesn't really force it for errors either. So like the only way to kind of force that for errors is to use a panic, because then it has to be recovered or else the program crashes. But we already know that that's an anti-pattern. So yeah, I don't know. I don't know what it would look like. If we could find a way to make it uh, feel like Go, then that's cool. So we have a question here from Sparky. Are you familiar with the Go project Pocket Base? It's an all-in-one Go backend like Supabase. Are you familiar with it? I really like this project as inspiration. Do you think it's any good? Um, I am familiar with it. We talked about it on the Cup of Go podcast a few months ago. I think they had a new major release out. I've never used it though. My co-host Shai has played with it a little bit, and he seemed impressed. But I don't have any direct experience with it, so I really can't comment beyond that. I'm curious. Have you been playing with it? What have you found? Was it Yeah, what are you using it for? If you don't mind sharing, what are you using it for, and how's your experience been? I'd love to hear, and I'll share that with the other watchers. I'm through my list of questions on the chat. I think if I missed your question, just repeat it. Um, I'm trying to go through the whole thing here. I should be showing this on the screen. I'm very not coordinator today. I'm going to check my email quickly and see if I got any email questions that I haven't already covered. Give me 1 second here. So I got the question about math. Yep, that one's in there. Looks like that's the only one I got in my email. So Thanks for repeating it on the chat. That's great for anybody who's watching the chat later. Anyway, any other questions anybody has? It could be Go, it could be programming in general. I could talk about continuous delivery. I could talk about more testing and mocks. I can go to more detail. I could talk about my favorite flavor of ice cream, which is pistachio, by the way. I like the comment here in the email version of the question about generics in the math library. It says, in my opinion, the Go team has taken the let's minimize the language too far. Keeping Go small is nice, but it should not extend to the standard library. Yeah, and I like that opinion. I don't know if I agree with it 100%, but I like that. I like that you said that. All right, got a few more questions here. This is great. I recently bought the Writing and Interpreter in Go book and started reading it. I realized I'm just copying the code from the book rather than doing it myself. Any advice as to how I should go about it, but actually want to learn? I tried to write an interpreter once, many years ago. I didn't get really very far. There was an online course I followed, free one. I don't remember what it's called right now. My advice, I've thought about doing this myself too, just as a fun learning project. I don't know. I don't know. You're probably not as old as I am because most people aren't. Most people watching a live stream like this aren't as old as I am. I used to have a Commodore 64, and my first programming language was Commodore 64 Basic. I've had the idea. I think about it every now and again in the shower or something about writing a Commodore Basic interpreter in Go, just for fun. So that could be the kind of thing you do. Maybe you use an Apple II or QBasic or something like that. That might be a way to go. Build an interpreter for a language that you've enjoyed from the past as a learning project. Because I don't know, I haven't read that book. I don't know what language they're having you interpret. But that would be one approach. That's probably the way I would do it. I would probably choose Commodore Basic just because I was familiar with it 30 years ago. I don't remember most of the details anymore, but it would be a fun sort of walk down memory lane to do that again. If there's not a language like that, if you're younger than I am, and you probably are, and you don't have some past language that you thought was interesting, maybe you don't want to do that, but you could still pick an old language and reinterpret it, right? Or write an interpreter for it. You could probably download the Commodore 64 or Apple II Basic or whatever guide online and get a list of the syntax as sort of your spec, or just use that as like, maybe you don't want to do it exactly like that, but use that as an inspiration, as a jumping off point, and then you go from there. So you have like your own version of Apple Basic or whatever. That would be an approach that could be fun. Or if you don't want to go with a legacy language, you could pick something more recent. You could build your own shell interpreter. Maybe there's something you don't like about Bash. This week's coming episode of Cup of Go, we interview somebody who wrote a shell in Go called Elvish. So maybe tune into that episode and get some inspiration from him. He talks about some of the things he wanted to improve from traditional POSIX shells. That would be an option. There's a lot of very specific sort of scripting languages that you might take inspiration from. I'm just trying to think of some examples that might, hopefully one might trigger your interest. Maybe you do gaming. A lot of different games have their own scripting languages or could be scripted. I was playing with Fallout 4 mods several years ago before my kids were born, and I wanted to make. I noticed that all the people kind of look the same. So one thing I was working on, and I didn't get very far, but I was making NPC, non-player character body generators that would give more proportional sizes. So some would be short and tall, some would be short, some would be tall, some would be fat, some would be skinny, different things like that. And I wanted to give like this sort of bell curve of what's normal. So in the game, like 90% of people are thin and attractive. Some are dirty, but they're thin and attractive. And like 1 out of 20 would be a little bit overweight or something. And I wanted to have it like more normal. So maybe I want to write a script language to help me do that sort of thing. Maybe that would be something you can write an interpreter for. Maybe a limited version of, who knows, JavaScript or Python or whatever. I don't know. I don't know if any of that's helpful at all. Yeah, those are my thoughts. I don't know if that's helpful. Um, is there anything you look forward to in Go? A lot of things I look forward to in Go. Um, let me think. So Go 122 just came out last month, and there's been a lot of good stuff in there. Go 121 had structured logging, which was really important. I'm looking forward to the new JSON library. I don't know when it will be in Go. It probably won't be in 123, maybe 124. There's a JSON experiment um, repository where some work is being done, but it hasn't yet even become an official proposal, which is required before it can become accepted and then therefore part of the uh, uh, standard library. Um, but I'm really looking forward to the new JSON marshaling and unmarshaling API. Should be much more efficient. It should allow for better streaming. So the open source library I mentioned earlier that I maintain, Kivik here, does a lot of JSON over network, and some of it over HTTP, and some of it can be megabytes or even gigabytes or larger in size, which is very inefficient with the current standard libraries implementation because it has to read the entire JSON object before it can parse it. Now, I have some tweaks in my library to not be as inefficient, but the new version will be much more efficient. So I'm really looking forward to that. Um, and if I have time between now and whenever that comes out, I'll probably add a version of my library that uses the experimental package just so I can start seeing how that works and see what kind of improvements I get. But that's one thing I'm really looking forward to. All right, next question. I'm in college and have a bad habit hopping around language, so I just want to stick with Go till I'm proficient. All right. When I was in college, I did the same thing. I don't think you need to feel bad about that. So let me just start with that. You don't need to feel bad about jumping around, especially early on in your career. Uh, as long as you're able to get a job, I guess you're in college right now, so maybe that's not quite on the radar. But once you're on the job market, you need to be able to get a job. I I don't think hiring managers are going to care very much about which language you know or languages. If you know Go or JavaScript or Python or Java, whatever, any modern language, PHP, Ruby, any language that's still being used, so not BASIC, not COBOL, um, you will be able to find uh, a job. uh, the main thing you'd want to focus on isn't the language per se, but the sort of coding you do. If you want to be a front end developer, for example, you need to learn React or Angular or something like that. If you want to do blockchain, you probably need Go or Python. If you want to do data science, you're going to be doing Python. So that sort of thing. So I would focus mostly at this early stage of your career. I'd focus mostly on your area of interest if you have one, and if you don't, that's okay too. Rather than the language, if you choose to stick with Go, that's fine. Go is a great language, obviously. I like it a lot. Um, but from a career perspective standpoint, it doesn't really matter at this early stage what language or languages you use. And trying several can have many advantages. I mean, you just saw me stumble through a question about a feature in Rust that I don't know because I don't know Rust. If you play with Rust for even 30 days, you'll be able to answer that question better than I can. So playing with a variety of languages a little bit can be very valuable, just because it gives you a sense of what's out there, and it makes you more well-rounded. But I wouldn't worry too much about that right now. When you're early in your career, it's okay to play. It's okay not to be focused. Nobody expects you to be a Go expert by the time you start your first internship or your first job out of university or whatever. Nobody expects that. They expect to hire a junior developer who's smart and can learn whatever language or languages and frameworks they use at that company, and that's fine. So I wouldn't stress about it too much. If you enjoy playing with Go and with Rust and with Python and whatever, that's awesome. There's no problem there. Now, if you're 50 years old and you're getting, and you've been doing programming for 30 years, more than likely you're going to change your view anyway. I mean, I'm 40, almost 45, and I've been focused on Go almost exclusively for several years now, with a little bit of a few other things as needed. But I haven't spent any time learning new languages just for fun for a long time, because my priorities have changed, and that's natural and that's okay. In fact, I kind of wish I had time to play with other languages. I'd love to play with Rust or with Erlang or whatever, but I don't have the time because I'm focused on my career and my other things. So I wouldn't worry about it. Enjoy the time while you have the time and the curiosity and the freedom to play with other languages. By all means, do it and don't feel bad about it. You will still be employable when you're ready for that first job. So Omar Tariq says that Tailscale has started using the Node.json library. Yeah, I'm not surprised. That's pretty cool. I mean, I think it's close to stable. It will probably change a little bit before it lands in the standard library, but yeah, I'm not surprised at some places where they are performance critical in particular will be using that. New question here. In some cases, I find myself using reflection. Are there any cons for using it? There can be. There are times when it's necessary. In general, reflection is slow. uh, don't let that deter you if you need to do it, though. I mean, it's useful also. uh, but if you have an alternative, like a type assertion, it's generally going to be faster than using reflection. So it depends on what you're using it for. I have one of my clients I'm working with right now has a lot of reflection in the code base, or that they did in the past. I've been removing it. And I have been able to replace large amounts of that reflection with generic support since Go 1.18 came out. So it depends on what you're using it for. It definitely can be appropriate. The downside. So I should also mention that. So the question was, what are the cons? One obvious con is that it's slower than alternatives when the alternatives exist. Another is that you have to be very careful with it because there's not a lot of safety around reflection. You can easily end up with a panic or trying to reflect something to a type that it isn't. You have to do a lot of inspection, reflection on the data you're manipulating to make sure it's what you expect, and that also lends itself to a lot of verbose code that's hard to follow and understand. So yeah, I think those are the three things. It's relatively slow compared to alternatives when possible. It's fairly error prone, and related to that, and one reason related to that is that it also makes for very difficult to read and verbose code. And part of that is because it's so error prone. You're trying to check all these corner cases and stuff. So those are I would say the three big reasons that the three big cons to using reflection. That doesn't mean don't do it. Sometimes you still need to. Pardon me. My voice is starting to go. Any other questions? We've been going on how long? 48 minutes? All right, another question. Great. I have basic knowledge around concurrency in Go. Is there any resources or type of projects you recommend to master the subject? I'll start with not answering the question by saying, although concurrency gets a lot of attention and it is a great feature of Go, it's often overemphasized. Like you don't need to be a master of concurrency in Go to get the benefits of Go, and even to get the benefits of concurrency in Go. Because a lot of it's just sort of handled for you. If you write an HTTP server, you're already writing concurrent code without ever knowing it, because every request is handled in its own Go routine, and it just works that way. That does mean that you have to be careful, and you have to be careful of this, regardless of whether you're doing concurrency or not. You have to be careful that the data you use is concurrent safe when it might be read from multiple Go routines. So that's kind of a tangent. It's related to concurrency, but whether you're writing the concurrent code or not, whether you're using the Go keyword or not, you need to make sure your data is safe. If you're not already, use the race detector when you run your tests. I have a video about that on my channel if you haven't seen it. Always use the race detector to help you find those bugs. But to the heart of the question, are there resources or types of projects to master the subject? Um, Probably like conceptually simple type of project to work on would be anything with well, like a fan out, fan in type of architecture, or even just a fan out. Like, so a very common sort of intro to concurrency project I've seen is a web crawler, something that downloads a web page, maybe google.com or maybe your company's website or whatever, parses it, looks for all the links, and downloads each of those links, and each of those it does the same thing, kind of recursively. So that could be a project that you do. Um, and then maybe I mean, I don't know what you do with those pages. Maybe you download all the images and cache them somewhere, or maybe you just create a directory listing of here's all the files, here's the path I downloaded, and here's how many bytes it had, or whatever. It doesn't really matter if the point is just a learning project. Just you could build a web spider that just downloads one page, uh, parses it very simply just to extract links, and any links it hasn't already visited, it triggers the same process. So you end up with this explosion of jobs you need to do, and the naive approach. I mean, so the sequential approach is just do that. Fetch the first page, get your list of say 10 URLs that are linked in there, add them to your queue. Start at the top of the queue, read the first one that has 10 URLs, add it to the queue, and so on. Now, of course, you want to keep track of which ones you've already visited, so you don't do them twice. So you have a list of ones you visited plus a queue, and you only add it to the queue if it's not in the list of already visited URLs, etc. So that's the sequential version. The naive parallel or concurrent version is you just start a go routine for each one of those, and that adds a certain amount of complexity because you need to suddenly use mutexes or some sort of protection to make sure that your queue and your list of visited sites, you don't have data races when you're updating those. Then you're also going to have a problem that if you just start a go routine for each one and you visit a busy website, you might suddenly have 6,000 go routines running or 100,000 or whatever, and then they're all going to slow to a crawl. You might even crash if you don't have enough memory on your computer. So you probably want a worker pool and say I want to run a maximum of 10 concurrent requests or 20 or whatever number. So then you get introduced to worker pools. So that might be a simple project, um, a web spider. That's probably what I would start with if you haven't done anything like that yet, because it's going to introduce you to basics of Go routines, um, memory, safety of memory management with either locks or mutexes or whatever, and a worker pool. That's probably where I'd start. And what you do with the results of that crawl are much less important. You could discard them. You could save them as files on your disk, turn them into, I don't know. That doesn't really matter. That's not the point of the exercise. What book are you currently reading, if any? I just finished a book. I didn't actually read every page, but it was called Shipping Go. I plan to make a video about it. Let me find it here. I think it was a Manning book also. Yeah, it's also from Manning. So I just finished reading this one. I would describe it as an introduction to DevOps from a Go perspective. It's kind of a loaded phrase because DevOps can mean different things, but like it's about building, deploying, and operating your software written in Go. So that's one I just finished. What am I reading right now? I think I haven't finished. I'm still reading. Let me remember what it's called here. Is it Lean Software Development? Can't remember the full title. There's several books with similar titles. I think this is the book I'm reading. It's an old book, um, but it's about applying lean manufacturing principles to software, which is kind of blasé these days. Like we hear a lot of talk about that stuff, but it was pretty new when this book came out, which was when was that? Where's the copyright date? Here, 2003. So it's 20 years old. Um, but the idea of lean in software was new then. I mean, this book sort of kicked that off. So I've been reading it. It's a really easy read and it's interesting. Like each chapter is kind of full of some profound wisdom. So I'm enjoying it. I need to get back to it now that I finished the Shipping Go book. So that's what I'm reading right now. All right, we're an hour in. Any other questions, or should I do some live coding? We have 8 people now. I saw only 7 earlier, so we had somebody join. Whoever that was, welcome. I don't know how recently that was. In the last 15 minutes, I guess. All right, let me get a drink and clear my throat, and we'll start doing some coding here. So I have a couple of options here. If anybody has an opinion, there's a few enough people on this call that a single opinion might be the winning vote. But I have 2 projects I can work on. In the past several weeks, I've been working on Kivik, the open source project I mentioned earlier. I could work on that some more. Last week, I kind of got stuck with some hairy SQL stuff. That's still where I'm stuck. So if I do this, if I work on that project today, it'll be debugging like multi-part join SQL queries. If people want to watch that, let me know. The other thing I could be doing today is another project I just recently started. It's kind of like GoFumped. It reformats your Go code, except it doesn't just like change indentation. It actually rewrites parts of your code to be shorter or more performant or more readable. So I could add a feature to that. Any preference for what I do? If I don't hear a preference, I'll probably do the rewriting tool, just because I think that's probably more interesting than watching me stare at SQL. So if you have a strong opinion, let me know now. Otherwise, I'm going to start pulling up that project. Let me share my screen again. There we go. All right, so let me pull up my editor in my console and we'll start coding. GoFund project. All right, we got a vote. I'm still looking for a name for this project, by the way. So if you have some great idea for a name, let me know. I'd love to hear about it. I have a working title right now, which I don't really like. I'll explain it here in a second. It's not a perverted name as you might think when you see it here. So I'm calling it Denude right now because I looked up what are things gophers do, and when gophers eat all the vegetation in an area, it's called denuding that area. So that's how I came up with the name. I don't think I like it. I think people are going to see that name and think that it's some sort of pervert thing, and it doesn't really describe what I'm doing anyway. So, but that's what it's called right now. All right, let me pull up my editor. And let me pull up my to-do list. We can pick a feature to add. So here's a list of features I might add. I don't know if I'll do all of them. And I might do one of these additional ones. Maybe I'll start with this one. So the idea is if somebody has code that looks like this, I want to convert it to this. It's functionally identical. There's no chance of introducing a bug by making that change, but it's shorter and more idiomatic. Let's do that. Let's, what should I call this rule? Call it plus plus. Although, and then you can also see up here is a related rule. I'll probably put these together. So if I have x equals x plus 3, that can be shortened to x plus equals 3. Similar for the minus and plus, or minus, plus, times, and division. So all of those can be done together. I'll probably make a single So the way this project is organized is I have these different analyzers, and each one handles a related, a specific rewrite rule. So I need a name for this rewrite rule. These are arithmetic operators. What should I call this rule? For now, I'm going to be stupid and clever and call it GPP, as in Go++, kind of like CPP for C++. I'm sure I'll rename that, but for now I'm going to call it that. Branch. Okay. GPP, Go++. All right. So I'm going to change to my analyzer directory. Short increment, yeah. Yeah, if it was just for that, although it could be for a decrement. And let me pull up the Go spec here quickly. By the way, this is a great time to mention, I'm pulling up the specification for Go. I have a daily email list where I talk about the Go spec. If you're not on that list already, you probably would enjoy it if you're interested in Go. If you go to boldlygo.tech/daily, you can sign up, type your email address there, and you'll get my daily emails where I explain some small part of the Go spec. Like this is the one from today, where I'm talking about constant expressions. So yeah, you should definitely sign up if you're not already signed up. But I'm going to the Go language spec because I want to look up the plus operator and the related one. So there's plus and minus and minus. So there's increment and decrement. We don't have times or divide, but we do have, I think we have times equal. Yeah, we have times equal, divide equal, plus equal, minus equal. And there's actually a few others too. There's like or equal. So we have some of those. I probably put them all in the same rule because they're pretty similar. They're conceptually similar, and I think detecting them will be similar enough. I'm going to go with GPP for now with the expectation to change it. Because I think increment is just too specific for the thing I'm doing, which means PP also is too specific, but whatever. So I'm going to copy one. I think I'll do sprint because that was a fairly simple one. GPP, and then I'll rename. Rename the package to GPP for now. Replaces how do I spell arithmetic? I'm terrible at spelling. Arithmetic expressions with shorter ones. I want to see if I think I already closed the window. Oh, here it is. What are these called? I don't know if these these like combined operators don't really have a name, but maybe how about op combine? Let's go with that. That's a better name than GPP. Combines arithmetic operators. How about that? All right. Add that to the list here. Up combine.analyzer. So I'm just doing some boilerplate right now. And these are the two rules we want to work on next, but I'll get to that in a second. So if any of you joined me early on when I started streaming a few months ago, I worked on a linter that used a similar test format. And that's where this is. This is the test. I'm going to clear this out. I'm going to just leave an empty main function for now. Don't need that. And I'll explain what this file does in just a second. All right, so there's my empty test. Oh, I need to change this message. Let me do that in a second. Or I'll do it right now. Oh, nope, wrong directory. I'm going to delete a bunch of stuff I don't need for this test. So inspect is the main function. I'm going to delete the bits I don't care about. I'm going to comment this out. I will need it, but not yet. Following arithmetic expressions that can be simplified. So here's where I want to copy from my todo.md. I want to copy those two rules from there over to here. Don't need that minus sign there. These are all in my to-do list right now. All right, that's good enough for now. I need to change this. So in my test here, I want it to have that output. All right, so let me explain this test file. This is a txtar file, which is, it's like a tar file in text format. And it has essentially three files in it. The first one here is, I guess it's called the header. I don't know what that actually is called, but that's what I'm calling it. And this represents the commands to run. And these use a particular testing tool from the Go, some of the Go authors. Probably won't talk about those details today. Then this here is, you can see this -- foo.go -- that means that everything after that line to the next separator should go into a file called foo.go, and then after that, foo.go.golden. So what this does is it executes this command, denude with these flags, fix and opcombine on foo.go. So essentially, I'm putting in foo.go the version that I want to be rewritten, and then in foo.go.golden, the version that should be rewritten too. So let me just do an example of that. Let's say var, let's just do x equals 1, x equals x plus 1. So that's what my input looks like. And I want that to be rewritten to x plus plus. Now, if I run my test, it should fail. And indeed it does. So the failure is that I got unexpected success. What that means, it looks like I'm covering up part of the screen. Let me see if I can fix that. Oh, that was easy. Now my head is in the other corner. So what that means, unexpected success, this exclamation point means that this exec is expected to fail. What does that mean? When denude finds a problem, or when gofumpt finds a problem, or any linter based on this architecture, which is what I'm using, it gives an exit and a failure exit status. Even though it's being fixed successfully, it gives an exit status. So the first thing that's wrong here is that this is not giving a failure exit status because I haven't written the logic yet to detect the failure. It's also failing because, although we didn't get this far, because the test suite stops, but it would also fail because this is not in the output, and it would also fail because this output doesn't match. So we'll fix all of those. So the first thing to do is to detect code that looks like this, right? I don't know exactly how we're going to do that, but we'll figure it out. That's the point. Now, there's a nice, handy online tool. Let me find the link for it here. 1 second. If you go to golangcilint.com, over here they have a new linter article in this tutorial. And I went through this tutorial on a live stream several months ago. So you can find that in the archives if you're interested, where I go through some of the more nitty-gritty of some of these details. But there's a link here to this online visualizer, which lets you paste in some arbitrary Go code and see what the AST, or the abstract syntax tree, looks like. So I'm going to take my little sample program here, and paste that in here. And here's what that AST looks like. Let me zoom in a little bit. So I'm specifically interested in finding the part of the x equals x plus 1. So there's x all over the place here. I think we're here. An assignment statement. Okay. Yeah, here we go. So we're looking for an assignment statement. And then there's the value, the variable there, x. All right, let's get started. So the first thing I want is to detect a node of this type. There's all sorts of nodes, of course, in our tree. But that's the one that's essentially the only one I care about at this stage. Where did my window go? Here we go. Let's do statement. Whoops. Doing a type assertion, so I do node dot, and then I put parentheses around the type. If not okay, I have Copilot running. That's what's doing this for me. Return true. Return true tells the parser to go on to the next node. Return false says don't parse further down the tree. So in all these short circuit cases, if it doesn't match, we return true to go on to the next node. In the success case where we found a match and we wrote it, we return false because we don't want to re-examine any children nodes. There's only a few in this case, but any children nodes, we don't want to re-examine those because we've already rewritten them. All right, so I'm going to add a little debug thing here. I have this dump node method that takes a node and turns it into text so I can print it out. So essentially all this is going to do right now is find any nodes in the tree that match this and then print them out for me. It should be one or two of those, maybe two. Yeah, there's two. So this counts as one, and this counts as one. Now, for now, all I care about is the equal operator. So, because I don't know what that's called. But I know that the one I have is called, well, I don't know what it's called. It's just called equal here. I'll figure it out. But I'm reminded of a case I want to add to simplify, and that would be if I have x plus equals 1, that can be simplified to x plus plus as well. So I'm only going to worry about this case for the moment. But I want to add this to my to-do list. This is my, if you read Kent Beck's canonical TDD, he says make a list of your tests. That's what this to-do is. This is the one I'm working on right now. These are the ones I have in mind to do later. So I'm focused on this one, but I just thought of this case, so I added it to my list so I don't get sidetracked too much. All right. So I think the next check I want to do is that the operator. Let me see here. So it says, so I have a left-hand statement and token. Let me look at the definition of this. LHS, left-hand statement, RHS, right-hand statement, token. So token is what I want to check here. So if stumpt.token is not equal, okay, add a sign is not what I want. That's got to be the plus equal, I believe. But let's just double check that. I think I just want a sign, but let me see. Yeah, so that's add assign, subassign, null-assign, quote-assign, rem-assign. So I want to handle all of these, probably these as well. But right now I just want, is it called assign? Where's the one that's just called equal? Assign, it's just called assign. So if I have a sign, if I don't have a sign, then return true. So now if I rerun the test, I should only see this line in the output, not this line, right? And that's exactly what happens. Okay. Okay, and I just thought of another case I want to add to my to-do list. there's different ways to write the same expression. I want to consider all of them. So I could have x equals 1 plus x should also be converted to x plus plus, right? Yeah. So I'm not going to worry about that case yet. That's why it's my to-do list. I'm only going to worry about the case I care about right now, but I don't want to forget that one. So now LHS is a list of expressions. So that, okay, I had to decide if I care about this. So here's the thing. Let me add this to my to-do list. I'm not going to do it today, but I might care about it later. So you could have an expression that looks like this: x comma y equals x plus 1, y plus 1. And I would want to convert that to this, right? So that's why this LHS is a list of expressions, because it might be x comma y comma z comma, there could be 100 different expressions there. And maybe some of those expressions can be simplified and others can't. So that would be a case like, let's say x comma y equals x plus 1, 3,000, right? And that should become x plus okay, that one that one can't just be, actually, this actually has to become a semicolon. So I'm probably going to just not handle that case. I could at least handle a case where I convert that to x plus 1. Let's do 4,000 in this case. Could become x comma y equals. No. I don't know what I want to do in these two cases. I don't know. So I'm going to not worry about that right now. So for now, all this to say, I'm going to only worry about the cases where LHS has a single expression and where RHS has a single expression. So length equals 1 in both cases, right? So I believe those lengths should always match anyway, because even though there's x plus 1, those are parts of the expression. So for now, I'm just going to check the LHS length. I think I can do it like this. All right, so that shouldn't change the output yet, but it does mean any of these sort of compound expressions or whatever will be ignored, at least for now. Maybe in the future I'll figure out how to handle those, but for now I'm ignoring that. And the next thing I want to check is, does the name of this variable match the name of this variable? So the first thing to check there is x of the first expression in AST.ident. This is going to be very verbose to start with. That's okay. I'll refactor it later to be less verbose. All right. So I have, let's call it, oops. LHS, okay. Yeah, okay. If not okay, return true. So if I have an expression that's not an ident here, so maybe it's a function call or something like that, or a basic lit like a number, so that would ignore. I'll add the other case here too, right? So I want this to become like this, right? So I'm specifically ignoring this case right now with this statement, because I'm checking that this should be RHS. So I'm specifically checking that the first operand in the RHS is an identifier. And in the second case here, it's not. It's what's called a basic literal. So if I run this, now that I've added that, I should have an error because I'm not using this yet. Blah. All right, so we're getting no output now. That's not exactly what I expected. Why is that happening? Oh, because this is a binary expression. Okay, let's do that. Let's change that. EXPR. Okay, so that means that I'm ignoring something like this first case, where if I had x equals 7, that would be ignored. I'm only considering binary expressions right now. And then let's call it x. So I'll call the first part of the binary expression x, the second part y. That's not without precedent. That's actually how it's labeled here. You see x and y with the operator between. So I'm going to say x. Yeah, it needs to be an ident. If not, okay, then return true. Except that should be exper dot x is what that should be. Something's failed. Oh, because I'm not using this x. Let me just do this. That'll silence that. All right, so I'm back to where I expected. I'm getting the right output, the right debug output. Now I need to verify that if G dot, yeah. I'm going to add an exception here. I'm going to say, let's add var y, x equals y plus 1. That should be unchanged. Let's call it int. Because this does not match this. And it's not being output. So if I comment this out, it should be printed now. Yes. So without this check, it continues through. With this, but with this check, it doesn't. So that's perfect. And now I want to check that the operator is the plus sign. If, yep, somehow it read my mind. And finally, I want to check that it's a basic literal. Let's call this y. And it's an integer. And it has a literal value of 1. All right, we still got it. Now we're going to do the rewrite. So I uncomment this boilerplate from before. Old text is the node, so that's statement in this case. And now I want to replace this with a new expression. I don't actually know what the type is. I have to look that up. Let's do it here. Let's add x++ and see what it calls that. I can copy that. It's called an inc_dec statement. Okay. Simple enough. So the new node goes here. And it takes a few arguments. We have x, which is, it can be x. It needs to be an ident that identifies the right variable name. So I could either copy x, which is this part, or I could copy the expression, or no, the statement, where is it? Statement LHS ident, which was this, but x is easier to get to and they should be identical, so it shouldn't matter. And then I need to set the token to ++. And this needs to reference statement. So this pause and end tell us where to overwrite in the target file. So pause is the beginning of the expression, statement is the end of it. Let's see if that works. All right, it did work, I think. Yeah, it did work. So the first case got overwritten. The second case is still wrong because I haven't done the reverse order yet. I'm going to commit this. All right. I'm going to get rid of this debug in just a moment. But first, let's generalize this now to support the other option, the other ordering. So what I care about here isn't per se that X is an ident and that Y is a basic literal, but rather that one of them is an ident and the other is a basic literal. So let me think about how I want to handle that. I'll probably create a helper function to do this for me. And I'm going to expand this helper function over time, but for now I'm going to call it, I don't know, is increment, I guess. It's not a great name. I don't want to spend too much time thinking about the name because it's going to change anyway. Let's do. Actually, is increment isn't quite what I want. No, I wanted. No, it's not quite right either. I'm trying to think what I. So I want the function to. I wanted to return an ident and a basic lit. I think is what I want. I just don't care the order. So I'll call it get binary parts. Let's do that. That's not great, but whatever. And so it'll take an expression of ast.binary expression, and it's going to return. Yeah, okay. I don't know if I like. I'm going to delete that for now. I don't know if I actually want Copilot's thing there, but I want to add some documentation first. A bunch of binary expression, regardless of their literal order. Makes it a little wider here. X will there we go. So that's what I want the function to do. And now I'm gonna let's see if this gives me what I want. It gets me close. So if not okay, so I don't want. That's not what I want. If okay, then I want to do this inside of here. So if X is an ident and Y is a basic lit, then I want to return XY true. Otherwise, the reverse, right? I'm not sure if this is the best way to write this code, but it should work. I can always refactor. So I did the opposite here. No, I don't want, I'm actually going to, Copilot's just making me confused. I'm going to copy this and switch X for Y. Okay, I'm going to put this inside of here so it's more locally scoped. Turn y comma x true. Return nil, nil, false. Why was this necessary to put that in a local scope? Because these are predefined here. Actually, I don't need them to be predefined here. I'm going to delete this. And instead of saying x will be, I'll say the first be the identifier and the second be literal. That way the positionalness of this is less important. Still like it being locally scoped though. Right, now I can call that from over here. I'm actually going to generalize this a little bit and just make this an expression. If expr is not a ast.binary expression or the expected types. So that's what I'm going to have this function do. So I need to add that by bin expr. I did that rename for the whole function so that this would be changed. I'm going to change it back to expr and then do bin expr. If not okay, then return nil, nil, false. Okay. The reason for that is to make it just easier to call this function right here. So now I can do x comma y comma okay equals blah and pass in that. And now I can get rid of all of that. Now I think it should work. Oh, I need to check for okay. Not okay, return true. Now I think it should work for both cases. Where's my little handle? Okay, it does, except for that part. I deleted too much, so I'm glad I put that test in there. So it got these cases right, but now it's collapsing this, and it shouldn't. So I need to also check that. Yeah, that's what I want. So x.name, the name of whichever. So remember, x is no longer position from this function, but it's the ident. Does that ident match the left-hand side's ident? If not, return false. That should fix it now. And it does. Let's commit this. All right, let's add support for the minus case. So x equals x minus 1 and x equals, well, I can't do 1 minus x, right? That's not mathematically the same thing. So actually, I want to put it there, though, because I want to test that I don't screw that one up. So this should become x minus minus. And this should remain unchanged. And right now, neither one. Oh, right now, they're both being. Oh no! Oh no! They're both being converted to plus plus. So that's not cool. I forgot to check the operator. So right here, or even before here. Okay, so if statement. Oh, wait a second. Okay, so actually, the whole work I did about this, I'm going to undo that now because I need. Well, or I could have this return the operator. Now, I'm not sure if I like this function at all anymore because in some cases the order matters, in some cases it doesn't, right? Because this thing that ignores the order, well, maybe I could have it be smart enough to only ignore the order for the operators that don't matter. Let me think. What are the other operators we have to deal with? Let's just copy this to my editor for the moment. Bring it down here. Start making my to-do list longer. I don't care about all of these. I do care about x equals x minus 1 gets converted to x minus minus. X, yep, that's right. X, yep, that's a perfect one. And then I want to do x equals x times 3 gets converted to x times equals 3. Yep, divided by 3. Perfect. Perfect. Yes, that's great. I don't actually know what that does, but sure. I don't know if that's gibberish or not. Now it's getting to repeating itself. Okay. Now a couple of these can also be done in other order. So let's multiplication and addition can. I think those are the only ones actually. No, some of these logical ones can, or bitwise ones. So x and 3. X equals 3 and x. That can be done the same with logical or bitwise or. And same with bitwise exclusive or, I believe. Now I need to look up what this operator does and see if it's something that we care about. Bit clear and not. Yeah, I don't think the order should matter there. I'll do some testing to be certain. But for now, I don't care that much right now. I just want to get these things down. All right. So a few of these operators, the order doesn't matter, and then a few of them do. So division, modulo. I think that's what that is. Remainder, yeah, modulo. Shifting. So some of those the order matters, some not. But I think I can have all handled in this same function here. I think I can put those smarts in there. I just need to have this also return the operator. So let me put that in here. Token dot token, I think is what it's called. I don't think nil is valid there. Copilot's not smart enough to help me out here. There we go. All right. So it's so this is the description is correct, but the behavior is wrong. I'll worry about that in a second. So what I want to do here is let's say new op equals token dot, yeah, why not? Token dot illegal switch op. So what I'm doing now is I take the operator that returned from this function, and based on what that is, I set the new operator. So plus becomes increment, and everything else is going to be illegal, which is going to break the thing, but that's okay right now. I expect this to break now. Yeah. So now we got actually illegal. So let's add the other case here. Token.sub becomes token.decrement. That should fix it. All right. It did. Except now this is broken because this function is not smart enough to know that in the case of subtraction, order is important. So let me rename, let me commit. No, I'm not quite, it's broken. I don't want to commit yet. Let me reword this documentation to express what I want it to do. Get binary parts returns the parts of binary expression, ignoring the operand order for operations where order is insignificant. Okay, that seems about right. And then I need to just update the logic to match. So the first part of this should be fine. But then basically here I want to short circuit if it's not for one of the types where the order doesn't matter. So if not, let me just do a switch here. For an expert op case. It's kind of picking up on the gist of what I want, but not doing it right. So I want to just fall through, and then default is return that. This list is shorter than the list of the list of operators that don't care about the order is shorter than the ones that do. So I want to list that, but that means I have to do this default case thing. This isn't a complete list though. Like we already saw a few that should be added, but I'll get there. Let's just run the test here and see how things go. Good, it's working now. I'm going to commit this. Don't need to commit that. All right, so now rather than just like trying to brainstorm on a list of all these things, I'm going to add tests for them. So I'm going to do that based on this list we have down here. Actually, I already did this one. That should have been part of the last commit. Actually, I'm going to delete this now. I don't need that anymore. But now I'm going to start writing these tests. To get them to see if they're working and make them work. So I'm going to skip the ones that don't use. So there's probably a whole bunch of variations of this, like plus equals 1 should become. Well, I thought of it. No, it's already here. That's here. We might have the same like. In fact, I'm sure we do. We want to have like x times equals. No, we don't. I'm thinking of nonsense. It's because there's only a single increment and decrement operator. Those are the only two cases of that. So what I want to look for now are the other cases where I have the form x equals x something number where the order doesn't matter. So let's do multiplication. X equals x times 3, x equals 3 times x. Both of those should become, I'm going to move these down here to a new section. Both of these should become x times equals 3. Oops. Except that, I haven't written that logic yet, have I? I've only done the increment and decrement. So I need to back up. Let's do these two cases next, since they have the same output format, even though the input is different. All right, so let's do that next. X plus equals 1 and x minus equals 1. Those should become x plus plus and x minus minus, respectively. That might be enough to finish up the hour. We'll see how we go. Or maybe it'll be faster than I expect. I put that in the wrong section. That should go up a little bit there. All right, those should both fail. And they do. And so I think the only place I need to check that, well, actually, I'm not sure if that, I think it's two places, but one place is here. So here we need to, right now we're only looking for the equals operator, right? Between the left-hand and right-hand sides. Now we need to support these other operators, the plus equals, the assign add and assign sub, I think they're called. We need to support those as well. That's going to change. Okay, I'm going to turn this into a switch statement. Switch statement.talk. Nope. So in that case, I want to do all this stuff here. Otherwise, so default, return true. That should change no functionality. Let's see. I broke something. Okay, so this op is accessed outside of that block. Is that the only thing that broke? X is also accessed outside that block. I'm not going to use X here anymore since I'm using different forms, because like over here, there is no X. So I'm going to use the left-hand side name. Now I have a reason to care about that. So that should solve that problem. Yeah, but now we have this op thing that needs to be handled. So let's put op token.token. Now we have this problem that this version is redeclared here. So it shadows that one. So I have to solve that. Let's call it. Let me think about this for a second. Well, let me solve the immediate problem first. Let me just call this bin op. It's in your name. I don't know what it should be, but I'll do that. And then I'll say op equals bin op. It should solve it. It should be working again. It's working as expected. So these two failure cases are still the same ones as before. So now I'm going to add the new case. Case token dot add assign. Okay. That seems reasonable. Yeah. Does that solve it? Is that it? That's all I needed. That's pretty sweet. And then subassign op equals. Okay, so that solves those two cases. That was really easy. So basically, except that, this is actually broken. Let me show you what I mean. I have x plus equals 3. This should say x plus equals 3, but it's going to say x plus plus. That's broken. So I need to not only do this, I need to also check the the right-hand side value. So if I just got a comment, thanks for the YouTube content or for the content you make. Yeah, thank you. Thanks for the kind words. I'm happy to do it. I enjoy it. So I want to check if stmt.l. Well, actually, that might not be far off. I do expect the right-hand side to be exactly 1. Turn true. Okay. I also expect it to be, I don't want that. I expect it to be um, I expect it to be an integer, kind of. We'll get to that. So if well, it's not LHS though, is it? No, that's RHS that I'm caring about here. Actually, I should put this above the switch statement because that applies to all of these. Like I don't want x comma y comma z equals different things. I'm ignoring all those right now as we discussed earlier. So this is not relevant anymore. Instead, I want to check the right-hand side that it has a length. No, not its length. I want to check this element is the equivalent to y. Yeah, okay, so let's call it y. Come on, okay, yeah, no, that's what I'm looking for. That's what I'm looking for. If it's not that I return, and if it's not an integer, return true. And if its value is not 1, return true. All right, that should solve that particular instance. Yes. It's still broken for the minus case though. So x minus equals 3 should not be altered, and it will be. So I need to copy all this logic down here. Now I have a bunch of duplicate code, but it should work. So there's the green stage of red-green refactor, right? Let me move some of these to-dos. Which ones did I just do? I did both of these. Let me move those up here. Support x plus equals 1 to converts to x plus plus, and x minus equals 1 converts to x minus minus. All right. I'm going to start to wrap up here, but I'm going to add a few more cases to this because there's several things that are still missing here. And I don't just mean these. I mean several categories of things that are missing here. You may have noticed that I only look for integer literals. What if we have an int 64 or an int 8 or something like that, right? So I'm not gonna enumerate all of those. I'm just gonna add notes here. Well, all of those. I mean, I could duplicate every one of these for every type, right? But I don't want to do that. Can you do a plus plus for a float? I don't know. Actually, sure. I don't know if that's possible. Googling playground. Let's find out. I suppose you can, but I've never tried. So let's say zoom in a little bit. X float 64 3 x plus plus. Yep, works for floats. So I need to do float 32 and float 64. Maybe a complex too. I don't think so. I've never used a complex number. I probably don't care about that, but I need to do this. I also need to support named constants. I think that's it. That's all I need to support for these or plus plus and minus minus, right? Because I could have I'll just type a demonstration here. Const 1 equals 1, x plus. Actually, you know what? I don't want to do this for named constants. Let me show you what I mean. But I just decided I don't want to do it. But I could have x equals x plus 1. That could be shortened to x plus plus, but that hurts readability because that constant is significant. What if somebody changes that constant? It should change this case too. So I do not want to support that. I only want to support that for literals. So that's actually not bad. But for everything else, I want to support constants. So I do want to turn this into x plus equals 1. So and then in that case, I need to support named constants, variables, and functions for everything other than plus plus minus minus. So I could have x equals x plus legs. I don't know how many legs you have on your animal. That could be 6, and that should become x plus equals legs. I could have x equals x plus foobar as a function, and that should become x plus equals foobar. So I need to have all those versions supported for all of these other things. There's a lot to do there. None of them are difficult individually. The trick for this sort of coding is to make all of this code not more repetitive than necessary. I'm going to delete this debug now. I don't think I need that anymore. I can add it again later. Add some more, add to do, and remove debug code. I'm going to call that a day. I have another question here. Question: would you have Accenture project, a Go-based open source project that an intermediate Go dev like me could contribute to, or where I could find a list? I've seen questions like this a few times too. I don't know a great answer to that one either. I mean, there are many open source projects that will have like a list of good first contribution or things like that. But my personal advice for that sort of thing is to pick a project you care about. I've never seen great success with just looking for a project to contribute to. That's not to say it doesn't happen. Maybe it does, and I just haven't seen it. But I've never heard of anybody becoming a successful open source contributor by looking for a project to help with. Rather, look for a project you use or care about and start helping. That's my advice. So I don't know what kind of experience you have, what kind of projects you do. If you're into gaming, maybe there's an open source library used for work that has a bug that you could fix, or maybe maybe you use let's say you use Echo framework at work and you hate it. So at home you want to use something else. Maybe you start contributing to Qi or to Revel or whatever. Some competing framework or whatever. Pick a project you like or that you care about. Ideally one that you use, but at least one that you care about, because that will keep you motivated far more than a random project that asked for help. I've had people ask to contribute to my open source project, kind of in this vein, like, hey, I just want to get involved in open source. Can I help you with your project? I say yes, and I never hear from them. I never hear from them. So the most important thing is a project you're motivated to help with. Second to that, you want a project that will help you get started, and not all open source projects will do that. It depends on how mature it is. If it's a really small thing with a single contributor, kind of like mine, it may be hard to get involved because maybe they don't have the time to bring you on board or to get you up to speed. But if you can do as much of that yourself as possible by just contributing useful help, contributing useful fixes, whether it's even just documentation fixes or bug fixes or bug reports, just get involved, and that will help with that. That won't overcome a completely non-responsive maintainer, of course. So in that sense, the larger the project, the better, because you're more likely to have somebody who can review your code and get involved with you. But the most important thing is one that you're motivated to stay with. So I would look for a project that you already use or are willing to use or interested in for some reason. That's my best advice there. I hope that's helpful. We're at 2 hours. I'm going to end. thanks for sticking around. A few of you, it looks like there's 3 of you still here, stuck around after the Q&A session. So thanks if you were here for both parts. It was a lot of fun. I do this every Monday at the same time from 2 till 5 my time in Europe, which is if you're in the US or wherever, it's a different time. But I try to do it this same time every week. So hope to see you here next week when I'll be doing some more of this. And later next week on Thursday, I think, I'll be doing a follow-up to 2 weeks ago. I did a pair programming, or 3 weeks ago, pair programming live session during this section with Dennis and Adrian, and we're going to do that on their channel. So on Thursday. So stick around for that announcement. I'll mention once more, boldlygo.tech/daily. If you're not already on that list, subscribe there. You'll be notified by email with the details for that live stream coming up next week on Thursday. And you'll get notified for this one every Monday. So thanks. Hope to talk to you all soon and hear from you soon. Have a great week.